So today's topic is Introduction to Matrices, and it entails order of matrix, addition, subtraction, and multiplication of matrices. A definition of a matrix is that a matrix is a group of numbers arranged in rows and columns. Each number in the matrix is called an element. Elements A, B, C, D, E, F, G, H, I. Rows are elements in a straight line. Columns are elements vertical line. ABC is on a straight line, that's row 1. DEF, row 2. GHI, row 3. ADG is arranged in a vertical line, that's column 1. BEH, column 2. CFI, column 3. It is very important for you to know the difference between rows and columns when it comes to order of matrix. So order of matrix is number of rows multiplied by number of columns. So for example, 2 by 2, this means this matrix has 2 rows and 2 columns. 2 times 5 means it has 2 rows, 5 columns. 3 times 2 means it has 3 rows, 2 columns. 3 times 3 means it has 3 rows and 3 columns. So the first number represents rows, second number represents columns in the order of matrix. So we are given this example K of a matrix K which has elements -1, y, 6, 9. It's a 2 by 2 matrix since it has 2 rows and 2 columns. Row 1 is -1y, row 2 6, 9, column 1 -1, 6, column 2 y, 9. So the next thing we're going to talk about is rank of matrix. The rank of matrix tells us how much useful information is in the matrix. It measures how many independent rows or independent columns there are. So independent rows or columns are rows that contain new information. They don't look like a copy or combination of other rows. Think of it like this. If you have 3 sentences, but 2 of them just repeat the information from the first one in different words, you really only have one new idea. In the same way, if rows or columns repeat or are combinations of each other, they don't count as new. So how do you find the rank of matrix? You find the rank of matrix by counting how many rows or columns contain new independent information. So example 1, matrix T has elements 1, 2, 1, 2. It's a 2 by 2 matrix. Since it has 2 rows and 2 columns, find the rank of matrix. If you look closely, the second row is the same as the first row. This means the second row does not give new information, so we only have one independent row, which is row 1. Therefore, the rank of matrix is 1. So you can choose to use either rows or columns. So in this case, column 1 is 1, 1, and column 2 is 2, 2. So if you look closely again, the second row is just the double of the first row. This means the second row does not give new information. So we only have one independent row, which is row 1, which is 1, 1. Because the second row is just the double of the first row. So this proves either way you can use rows and columns or columns to find the rank of matrix. So in this question, the rank of matrix is 1. So this example 2, we have matrix R, which has elements 1, 2, 3, 4. Find the rank of matrix. So again, we can choose to use rows or columns because either way, the answer will be the same. So row 1 is 1, 2. Row 2 is 3, 4. So here, neither row is a copy of or multiple of the other. So both rows provide new information. This means the rank of matrix is 2. For the people who chose to use columns, column 1 is 1, 3. Column 2 is 2, 4. Column 1 is not the same as column 2 or a multiple of column 1, so it's independent. Both column 1 and column 2 are independent. That means the maximum number of independent rows or columns is 2. Hence, the rank of matrix is 2. So the next thing we're going to talk about is addition. And we're given this example. Given matrix P, and those are your elements, -1, 0, 7, 15, 2, -6. And matrix Q is 4, 6, 22, -5, 8, 3. Find Q plus P. So something important to note is you can only add matrices that are the same size, which means they must have the same number of rows and columns. So step 1 is to look at the 2 matrices you want to add and add the numbers or elements that are in the same position. For example, if two matrices both have a number in the first row and first column, add those two numbers together. Do this for each pair of corresponding elements. So let's go to our solution. We add 4 and -1 since they're at the same position. So 4 plus -1 since it's addition, 6 plus 0, 22 plus 7, -5 plus 15, 8 plus 2, 3 plus -6. So 4 plus -1, that means it's 3. 6 plus 0, 6. 22 plus 7, 29. -5 plus 15, 10. 8 plus 2, 10. 3 plus -6, -3. And there we have our answer. We have another example, example 2. We have matrix S, which has elements 0, -1, 4, 7, 2, -8, 22, 5, 11. And matrix R has elements 3, 2, 0, -17, 4, -6, 32, -8, 20. Remember, in order to add two matrices, they have to have the same order of matrix. So in this case, S has 3 by 3 order of matrix. R has 3 by 3 order of matrix since it has 3 rows and 3 columns. Those are the requirements in order for them to be compatible for addition. So in the solution, again, we add 0 with 3 since it's in the same position. 0 plus 3, -1 plus 2, 4 plus 0, 7 plus -17, 2 plus 4, -8 plus -6, 22 plus 32, 5 plus -8, 11 plus 20. So 0 plus 3 is 3, -1 plus 2 is 1, 4 plus 0 is 4, 7 plus -17 is 10, -10, 2 plus 4 is 6, -8 plus -6 is -14, 22 plus 32 is 54, 5 plus -8 is -3, 11 plus 20 is 31. So the next thing we're going to talk about is subtraction of matrices. And subtraction is the same as addition. You can only subtract matrices that are of the same size, which means have the same order of matrix. Matrix R is a 2 by 2 matrix. Matrix Q has to also be a 2 by 2 matrix. So we follow the same step. We subtract the numbers that are in the same position. So in this case, we are given matrix E and F. So this is a 3 by 2 matrix, which means it has 3 rows and 2 columns, right? Remember, order of matrix starts with rows and then we go to columns. So it's a 3 by 2 matrix. Row 1, which is -4, 7. Row 2, 22, 8. Row 3, 3, -1. Column 1 is -4, 22, 3. Column 2 is 7, 8, -1. So it's a 3 by 2 matrix. So let's go to the solution. We're told to find E minus F. So we do -4 minus 0, 7 minus -1, 22 minus 12, 8 minus -6, 3 minus -18, -1 minus -2. So the answer is -4 minus 0 is -4. 7 minus -1, minus times minus is plus, so it's like 7 plus 1 is 8. 22 minus 12 is 10. 8 minus -6, minus times minus is plus, it's positive, so it's like 8 plus 6, which is 14. 3 minus again times minus is plus, so it's like 3 plus 18, which is 21. -1 minus again, so that's plus. -1 plus 2 is 1. So we have our answer, which is -4, 8, 10, 14, 21, 1. So our answer is the same order of matrix as the matrices we are given. The answer is still a 3 by 2 matrix. So the next thing we're going to talk about is multiplication of matrices. And multiplication of matrices is subdivided into 2 parts: multiplication by scalar and multiplication of two matrices. So we're going to start with multiplication by. So a scalar is a constant value. The scalar multiplies each individual element. So for example, we're given a matrix B which has elements E, F, G, H, I, J. And we're going to represent our scalar with lambda, right? So the solution is, so lambda times B, which is our matrix, is lambda times now our matrix B, which is E, F, G, H, I, J. We're going to take lambda times E, lambda times G, lambda times I, lambda times F, lambda times H, lambda times J. So we multiply the scalar with each element in the matrix. So here we're given example 1, given a matrix M, which is a 2 by 3 matrix. It has two rows and 3 columns. It's a 2 by 3 matrix. And we are told our scalar is 4. So evaluate CM, which means C times M, right? So it's 4 times matrix M, which is 2, -3, -2, 4, 0, 10. So we multiply the scalar, which is 4, with each individual element. So 4 times 2, 4 times -3, 4 times -2, 4 times 4, 4 times 0, 4 times 10. 4 times 2 is 8, 4 times -3 is -12, 4 times -2 is -8, 4 times 4 is 16, 4 times 0 is 0, 4 times 10 is 40. And we have our 2 by 3 matrix answer, which is 8, -12, -8, 16, 0, 40. So the next thing we're going to talk about is multiplication of two matrices. And not all matrices are compatible to multiplication. So the matrices that are compatible for multiplication is if the number of columns in the first matrix is equal to the number of rows in the second matrix. So we are given this example. So the first matrix is a 3 by 2 matrix, which means it has 3 rows and 2 columns. Second matrix is a 4 by 4 matrix, which means it has 4 rows and 4 columns. So in order for matrix to be compatible for multiplication, the number of columns in the first matrix has to be equal to the number of rows in the second matrix. So in this case, it's not compatible since the first matrix has 2 columns and the second matrix has 4 rows, and 2 is not equal to 4, which means it's not compatible. So in this next example, our first matrix is a 2 by 3 matrix and our second matrix is a 3 by 3 matrix. So this matrix is compatible since the columns in the first matrix is equal to the rows in the second matrix. So the second step after determining the matrices, if they're compatible or not, is to predict the product of the matrices after multiplying them. So the product matrix has the number of rows given by first matrix and the number of columns given by second matrix. In the example that we are given, the first example, the matrix is not compatible. So the product, it doesn't matter since even if you multiply it, it won't be possible to multiply those two matrices. But if they were compatible, the product will be a 3 by 4 matrix, since we take the row of the first matrix and the columns of the second matrix. So the second example is compatible. Compatible means it can be multiplied. So our product matrix will be a 2 by 3 matrix. We take the row of the first matrix and the column of the second matrix. So something to note is, for any two matrices under multiplication, the order cannot be reversed. So if you are told to find the multiplication of matrix A times B, you cannot start with B times A because it will change the whole thing. So here is an example for you guys to understand this properly. So we are told, given matrix A and B, find A times B, and the second question is find B times A. So the first step is to check if the matrices are compatible or not. So the first question is find A times B. So A times B, the order of matrix of A is a 2 by 2 matrix since it has 2 rows and 2 columns. The second matrix is a 3 by 2 matrix since it has 3 rows and 2 columns. So again, in order to check if it's compatible, the number of columns in the first matrix has to be equal to the number of rows in the second matrix. So the column in the first matrix is 2 and the rows in the second matrix is 3. 2 is not equal to 3, which means it's not compatible. That means A times B cannot be done since it's not compatible, so we don't bother multiplying it. So the second question is B times A. So B times A, B, the order of matrix is 3 times 2, which means it has 3 rows and 2 columns, times A, which is a 2 by 2 matrix, which means it has 2 rows and 2 columns. So 2 is equal to 2, which means it's compatible, right? So after checking the compatibility, the next step is to multiply them. So we multiply only B times A since it's the only compatible one. And remember, guys, we can predict the product of the matrix by checking the row of the first matrix with the column of the second matrix. So our product will be a 3 by 2 matrix, which means it will have 3 rows and 2 columns. Let's see if it's true. So we multiply B times A. Again, you can't reverse it. If the question asks for you to find B times A, you have to start with matrix B, you multiply it with matrix A, right? So again, we multiply each element with the same element in the same position. So with multiplying it, we take a row from the first matrix, which is matrix B, and then take column of the second matrix, which is of matrix A, multiply corresponding elements from the row and column, and then add the results of this multiplication. So this is what I mean. We take 6 times 2 plus 2 times 1. So we take the first row, multiply it with the first column. We take the first row of the first matrix, multiply it with the first column of the second matrix. So 6 times 2, which is 6 from the first row and 2 of the first column in the second matrix, plus 2 times 1, then 6 times 3, plus 2 times negative 4, then negative 1 times 2, plus 0 times 1, then negative 1 times 3, plus 0 times negative 4, then 7 times 2, plus 9 times 1, then 7 times 3 plus 9 times negative 4. So 6 times 2 is 12 plus 2 times 1 is 2. 6 times 3 is 78. So 6 times 3 is 18. So 6 times 3 is 18 plus 2 times negative 4, which is negative 8. Negative 1 times 2 is 2 plus 0 times 1 is 0. Negative 1 times 3 is negative 3 plus 0 times negative 4 is 0. 7 times 2 is 14 plus 9 times 1 is 9. 7 times 3 is 21 plus 9 times negative 4 is negative 36. So 12 plus 2 is 14. 18 plus negative 8 is 10. Negative 2 plus 0 is negative 2. Negative 3 plus 0 is negative 3. 14 plus 9 is 23. And 21 plus negative 36 is negative 15. So we predicted that our product will be a 3 by 2 matrix. And this is true since it has 3 rows and 2 columns. So row 1 is 14, 10. Row 2 is negative 2, negative 3. Row 3 is 23, negative 15. And the columns are 14, negative 2, 23, which is column 1. Column 2 is 10, negative 3, negative 15. So it's a 3 by 2 matrix. So we have another example here. Example 2, we are told given matrix J and F. So we have find J times F, and then the second question is find F times J. So the first step before multiplying is finding if it's compatible for multiplication. So order of matrix, right? So J, the order of matrix is 3 by 2, which means has 3 rows, 2 columns. And F is a 2 by 4 matrix, which means it has 2 rows and 4 columns. Again, rows are the ones in a straight line and columns are the ones in a vertical line. So row 1 is 7, 0, 18, negative 4. Row 2 is negative 1, 9, 6, 20. Column 1 is 7, negative 1. Column 2, 0, 9. Column 3, 18, 6. Column 4, negative 4, 20. Right? So it's a 2 by 4 matrix. So let's check if J times F is compatible. You check the first matrix, if the column of the first matrix is equal to the row of the second matrix, which is equal. 2 is equals to 2, which means J times F is compatible for multiplication. So let's check if F times J is compatible or not. F is a 2 by 4 matrix multiplied by J, which is a 3 by 2 matrix. So the first matrix column is 4 and the second matrix row is 3. 4 is not the same as 3, which means it's not compatible. And if it's not compatible, it means it cannot be multiplied. So we just calculate the first question, which is J times F, since it's compatible. I say that you can predict the order of matrix of the product after multiplying J times F by taking the row of the first matrix and the column of the second matrix. So the product will be a 3 by 4 matrix so the product will be a 3 by 4 matrix. Let's check if it's true. So let's multiply J times F. Again, we take the first row of the first matrix multiplied by the first column of the second matrix. So 2 times 7 plus 18 times negative 1. 2 times 0 plus 18 times 9. And then 2 times 18 plus 18 times 6. Then 2 times negative 4 plus 18 times 20. Then negative 1 times 7 plus 7 times negative 1. Negative 1 times 0 plus 7 times 9. Negative 1 times 18 plus 7 times 6. Negative 1 times negative 7 plus 7 times 20. 0 times 7 plus 9 times negative 1. 0 times 0 plus 9 times 9. 0 times 18 plus 9 times 6. 0 times negative 4 plus 9 times 20. So 2 times 7 is 14 plus 18 times negative 1 is negative 18. Negative 2 times 0 is 0. 18 times 9 is 162. 2 times 18 is 36 plus 18 times 6 is 108. 2 times negative 4 is negative 8 plus 18 times 20 is 360. Negative 1 times 7 is negative 7. 7 times negative 1 is negative 7. Negative 1 times 0 is 0. 7 times 9 is 63. Negative 1 times 18 is negative 18. Plus 7 times 6 is 42. Negative 1 times negative 4 is 4. Plus 7 times 20 is 140. 0 times 7 is 0. Plus 9 times negative 1 is negative 9. Then 0 times 0 is 0. 9 times 9 is 81. 0 times 18 is 0. Plus 9 times 6 is 54. 0 times negative 4 is 0. Plus 9 times 20 is 180. So 14 plus negative 18 is negative 4. 0 plus 162 is 162. 36 plus 108 is 144. Negative 8 plus 360 is 352. Negative 7 plus negative 7 is negative 14. 0 plus 63 is 63. Negative 18 plus 42 is 24. 4 plus 140 is 144. 0 plus negative 9 is negative 9. 0 plus 81 is 81. 0 plus 54 is 54. 0 plus 180 is 180. And we have our answer. So we predicted that our product will be a 3 by 4 matrix, right? And we are correct since it has 3 rows and 4 columns. So row 1 is negative 4, 162, 144, 352. Row 2 is negative 14, 63, 24, 144. Row 3 is negative 9, 81, 54, 180. Column 1 is negative 4, negative 14, negative 9. Column 2 is 162, 63, 81. Column 3 is 144, 24, 54. Column 4 is 352, 144, 180. So it's a 3 by 4 matrix since it has 3 rows and 4 columns. So that's our answer, and yeah, we're done with this topic, and I hope we meet again for the next topic, which is how to find determinants and inverses of matrices. Yeah, bye. Please don't confuse me. Liquid in my cup, I keep it juicy. I used to be like that way back then. I was way back then. I had